Now that we've learned about our inverse trig functions and inverse tangent in specific, we can start learning about vectors because we need inverse tangent to figure out the direction of a vector. That's why it comes at this point. And we're just going to touch on vectors and start getting familiar with them. Later on, we'll start using them for application problems, and we'll add them and multiply. But right now, we're just going to get a little intro. We're going to write them in component form, determine their direction and magnitude. Given the direction and magnitude, write a vector, and express in terms of the unit vectors I and j, which is pretty simple stuff. It's not hard at all. So, a vector is a quantity that has two properties. It has direction and magnitude. We often use vectors to describe changes in position. It's really good when you're talking about a plane moving and the wind, and each has its own vector. We use a horizontal and a vertical component. X usually represents horizontal, Y represents vertical. The initial position doesn't matter, just the direction and the magnitude. So, ways to write a vector. Boldface type, but since I can't write in boldface, I usually put a little arrow over it, and I'm usually too lazy to put both of the arrowheads. I just put kind of half of an arrow above them. Given an initial point P and a terminal point Q, the vector represented as PQ can be written as PQ with an arrow over the top. Given the initial point 0, 0 and terminal point XY, you can write it as XY because that would be the distance from 0, 0 to XY. We can write any vector using the unit vectors I and j. So I is all about side to side, j is all about up and down. We'll talk about it more later. A vector is drawn as a little line segment with an arrow at one end and a solid dot at the other. It has an initial point, that's where the solid dot is, and a terminal point, that's where the arrow is, because that's telling you that it's going in this direction. The magnitude of the vector is how long it is. So, position vector has an initial point at the origin and its terminal point at the point AB. That's said to be in standard position, and it's written in component form. So the initial point of vector CD is x1, y1, and D is x2, y2. So you find the position vector by calculating the distance between x2 and x1 and the distance between y2 and y1. And since direction matters, if it's going to be C to D, then you need to put the terms of D minus the terms of C. Now, consider the vector whose initial point is 2, 3, and terminal point is 6, 4, and we want to write it in component form. And just for fun, I'm going to go ahead and graph it too. So let's look at example 1. And since both of those points are in the first quadrant, that makes my life pretty easy. P is at 1, 2, 1, 2, 3. And Q is at 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So, initial point is at P, terminal point is at Q. Now I want to write it in component form, so I do my x-coordinate of Q minus my x-coordinate of P and my y-coordinate of Q minus my y-coordinate of P. And that gives me 6 minus 4 is 2, and 4 minus 3 is 1, and that should have been 6 minus 2 because it was the x-coordinate of my p. 6 minus 2, 4 minus 1. And let me tell you how I knew I was wrong, because I knew this thing was 4 units long, because in component form, it would be 1, 2, 3, 4, up 1. And it should look exactly like this one, as if I just picked it up and put its solid dot there at the origin. And there's the pretty picture. Okay, find the position vector given that V had an initial point at -3, 2 and a terminal point, then graph them in the same plane. So again, we're going to do pretty much what we did for this one. Example 2. We have initial point, I'm going to go ahead and name it P just because I can, -3, 2, and Q, my terminal point, is at 4, 5. So 1, 2, 3, 1, 2, 1, 2, 1, 2, 3, 4, 1, 2, 3, 4, 5. It looks something like that. So then my position vector would be equal to 4 minus -3, 5 minus 2. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. And you can see it looks kind of like I just picked this one up and shifted it over, but here's the pretty picture. So it really looks like you just shifted it over. So practice drawing vectors and position vectors. Draw a vector that connects the origin, that connects from the origin to the point 3, 5. Draw a position vector given that V had an initial point at 5, 2 and terminal point at -3, -1. And then find the position vector and then graph them. So you've got 3 to graph. Maybe you'll want to grab some graph paper. I think I will. Yeah, my pictures look so much better with graph paper and a ruler. Draw a vector that connects from the origin to the point 3, 5. So I just plotted the point over 3, up 5, connected the dots, solid dot at the origin, arrowhead at 3, 5. Find the position vector given that V has the initial point 5, 2 and terminal point -1, -3. Then graph them in the same plane. Easy enough. So I took x-coordinate minus x, actually x-coordinate minus x-coordinate. You start at the arrowhead. Y-coordinate minus y-coordinate. And it really does look like I just picked it up and moved it. This one was kind of funny because they switched roles, kind of. It's position vector given that it had an initial point at 7, 1 and terminal point at 0, 0. And so the position vector, its terminal point, became its initial point. So it looks like it just kind of shoots off in that direction. Okay, unit vectors are vectors that have magnitude equal to 1. That's why they're called unit vectors, and I haven't defined magnitude yet, but I will in a moment. The simplest ones are I and J. I goes directly to the right, j goes up and down, and they have length 1. You can write any vector as a combination of I and j. For example, the vector 4, 3 can be written as 4 times I plus 3 times j, because that's how vector addition works. So, given an initial point P is negative 1, 3, and Q is 2, 7. We want to write the vector in terms of I and j, so we do 2 minus negative 1 times I plus 7 minus 3 times j. 2 minus negative 1 is 3i, 7 minus 3 is 4j. And yeah, I told you, I just make kind of a little half arrow because I'm too lazy to write the whole arrow, and I can't write in boldface. So, your turn. Write the vector u with initial point P in terms of I and j, and you've got 2 of them. So, give them a try. It's easy stuff. It's just arithmetic. So, as long as you got the order right and you did your arithmetic correctly, you got these right. We do 7 minus negative 1 times I, negative 5 minus 6 times j. We do 0 minus 3i, 5 minus negative 2j. Okay, determining magnitude and direction. Magnitude is easy. It's just the square root of the sum of the squares. So we're calling this one V, magnitude of V, and V is equal to A comma B is equal to the square root of the horizontal component squared plus the vertical component squared. And sometimes it has just like absolute values around it. Sometimes you'll see it written with double absolute values around it. It depends on which book you're looking in. The direction takes a little more thought because you have to figure out which direction that vector is pointing, because you're going to take theta, the direction, is the inverse tangent of the vertical component divided by the horizontal component. But remember, that's going to give you an answer on the right-hand side of the unit circle. If your vector is pointed in the other direction, you're going to have to figure out exactly what it is. And you want it to be positive. So if you get an answer in quadrant number 4, you're going to need to adjust it so that it is a positive number. So let's try one. We want to determine the magnitude and direction of B, which is equal to, and I'm not going to write it in terms of I and j. I'm going to write it in component form, 2 and 3 with its little pointy brackets. So the magnitude is equal to the square root of 2 squared plus 3 squared, which is the square root of 4 plus 9, which is the square root of 13. And yeah, usually you're going to leave it just like that, square root of 13. Inverse tan of 3 over 2. Not a special special angle. And let's see, I have my radians here. I'm going to switch it to degrees, so just in case you haven't